So hey everyone, welcome to Tutort Academy. So my name is Chirag Vaishnav, and in this video we will be discussing the coin change problem. So it is a very standard problem. We are having two basically variants of this problem, that is namely coin change 1 and coin change 2, and we will be discussing each of them in detail. Also some other variants that are being asked, because this is the question that is one of the most favorite questions of the interviewer, right? Because in this they check whatever your basic DP skills are, right? So DP basically stands for dynamic programming, and we will be discussing that what it is, how it is happened, how we can learn that, and how we can implement that in our logic and our code, right? So first let's discuss that what will be the flow. So first I will discuss the problem statement, then we will be discussing that how we form the logic for building this problem, how the DP is being applied, and after that what we will be doing is, after that we will be seeing the code and how it all works, right? So without further ado, let's get started. So here we are. So the problem states that you are given an integer array coins representing the coin of different denomination and an integer amount representing the amount of money, right? So you are having an array, and in array you have all the coins like different denominations, like either 1 rupee coin or 2 rupee coin or 5 rupee coin and something like that, and you're having a total amount of money. Now what we have to do with the coins and money, let's see. So return the fewest number of coins that you need to make up to that amount. If that amount of money cannot be made after all the combinations, then you have to return -1, right? So you may assume that you have infinite number of coins in each kind of coin, right? So what does this mean is, we are given some coins, we are given a final amount, so we have to find the minimum number of coins by which we can get to that amount. If that's possible, return the minimum number. If that's not possible, you have to return -1. And the second condition is that for each coin you're having infinite number of supplies, right? So what does this infinite number of supplies means? So this infinite number of supplies simply means that you can take as much as you want, as many times as you want, right? So let's see that the below example. So in the example we're having coins 1, 2 and 5. So what you want the minimum number of coins to reach the sum 11. So won't it be 5, 5 and 1? But the question rises that okay, 5 is a coin, but you have used 5 twice, so that is the question. You can use duplicate coins. You are having infinite supply of each coin, right? So that's how we will be working on it. So I think that the question is pretty clear. So now let me just open the So now let's see on the presentation that how it looks like. So suppose let's say let's take the same example. We're having 11 as a final sum, right? So we are having let's say, let me make an array. So we are having 1, 2 and 5 and 5 in our array, and the final sum that we want is 11, right? So for that what we will be doing is either whenever how DP is being applied is, right? So for DP you're having two conditions. One is sub problems, right? And that one you're having optimal substructure, and that is having a sub problems, right? So what does this means? Basically it simply means that you can divide that particular problem into mini steps and build on them, right? This is the simplest word in which DP can be explained, that what you have to do, you have to divide that particular problem into small steps and build on them, right? So for 11, let's say we started with 11 here, right? For 11, what are the ways that you can reach? Either you can use 1 rupee coin. So what will be left? If I used a 1 rupee coin, then what is left with me? What is left with me is 10, right? Now you have to get the sum of 10. If I use 2 rupee coin, what will be the sum that I will be left with? The sum I will be left with is 9, right? And if I use a 5 rupee coin, what will be the sum I will be left with? I will be left with 6, right? So and similarly we will be building on that, right? So let me just make it up to you. So if I used, now for the 10 rupee coin, if I used 1, so what I have to do, I have to use for the 9, right? If I use 2, I have to use for 8, and if I use 3, I have to use for 7, sorry, 1 2, and if I use 5, I have to reach for 5, right? Now in the next turn, what you have to do, if I'm having 1, right? So if I'm having 1, what you have to do, you have to check for 8. If you're having 2, then what you have to do, you have to check for 7. And if you're having 5, what you have to do, you have to check for 4, right? So let me iterate you once more, and then we can get it to the final point, right? So if you're having 1, then it will be 5. If you're having 2, then it will be 4. And if you're having 5, then it will be 1, right? So you can see that this 9 is being appeared here as well as here. This 5 is being appeared here as well as here, right? So these are the problems that we have been repeating. We have repeating problems. We have repeating sub problems, right? Now, how to solve that is the main issue. So in that also, if let me just finish one of the things. Now, if I used 1 in this case, now, so it will be 0. This simply means that 0 means that we have reached the final state, right? So this will be our base case, right? So this will be our base case, and this will be the structure that we will be having, right? So if I'm having 1 here, so what it will do is, it will so it took me 1 coin to go to, I took first 5 and went to 6, then I took 5 again, then I went to 1, then I took 1 again, then I went to 0, and that is my final condition. So this whole period, or this whole thing from this branch will return 3 to me, right? 5, 5 and 1. Similarly, if I go on this side, they will return me the minimum number of coins that we'll be having, because if I'm having 0 at this base case, I will be returning +1. And if I'm not having 0, suppose if I'm having a negative number, this simply states, let's say, in the case of 4, in the case of 1 only, suppose if I took 2, in the case of 1 only, if I took 2, it will take -1. If it's -1, this simply states that there is no possible condition that I can take those coins and reach to the final state. So what you have to do, you have to return int max. Now the question again arises that why you have returned int max? Why not simply 0 or something else? So we have returned int max. Because what you have to do, you have to check the minimum number of coins. The question is simply saying that you have to check the minimum number of coins through which you can get to the required sum, right? And in order to receive that, what you have to do, if this is not possible, you have to take int max, so that whenever we will be comparing the minimum out of them, it will be removed, right? So next thing is that only, for getting to the minimum number of coins which we can reach to this 11, what you have to do, you have to take minimum out of all these 3, right? And similarly, for getting the minimum number of coins to 10, you have to get minimum number of all these 3, minimum number of all these 3, and minimum number of all these 3, right? So at each state, you have to call for the sub problems, and you have to go for the minimum out of all of them, right? And once finding for the minimum, the next thing that you have to do is you have to find memoization technique, right? Because we have seen that we have to calculate 9 here, again we have to calculate 9 here, we have to calculate 5 here, again we have to calculate 5 here. So isn't it will be smart to calculate it only once and then store it somewhere and then use it again and again as we have going for the requirements, right? So this was the basic logic behind it. So what we will be doing is, first we will be starting with the base case. Now for each iteration, for the number of coins, what we will be doing is we will be subtracting that. So, okay, if I use 1, then it will be I will be having 10 left. If I use 2, I will be having 9 left. If I use 5, I will be having 6 left, right? And similarly, we will be going on deep into the tree. We will be taking our base cases, we will be getting back with our answers, and then we will be building up on the tree, and then we will be finding minimum at each level, and at the end, the minimum number of coins will be our answer, right? So I hope you got the solution right. So now let's head over to the code so that we can explain, we can understand it in a more better way. Right, so here we are. So here you can see what you have done is, first we have used in DP array. So in this DP amount +1, and we have what you have done, we have initialized the DP to -1, right? So this is the basically memoization technique that we will be using, right? After that, what you have done is, you have called the minimum coin functions and returned the value of a, right? So now let's head over to the min coin function. So here we are with the min coin function. Now, so for the min coin function, first, as we have discussed in the tree as well, what will be the base cases? The base cases will be if the sum is 0. If the sum is 0, then what you have to do, you have to return 0, because this is the final state, and after that we will be building upon the tree, right? So return 0. Now, if dp of k is not equal to -1, we have to return dp of k. So at the end, I have discussed that there is a smart way of doing this. If we have calculated the results previously as well, there is no need to calculate it more further. So we will be storing it, and we will be discussing how we'll be storing it just after 2 minutes only, right? So be patient. Now what you have to do, you have to initialize answer with int max -1. So as I said that on each level I will be calculating the minimum out of all the things, right? So in order to calculate the minimum, we always initialize the variable with maximum and -1, because we will be adding +1 at each state so that it does not overflow the condition, right? So now what you have to do, for each coins you have to check if k minus coins I is greater than 0, right? So in this also you might remember that in the case of 11, I took like 11 minus 1. So 10 is greater than 0, then only I use 10. If 11 minus 2, 9 is greater than 0, then only I use 9. 11 minus 5, 6 greater than 0, then only I use 6, right? Because it is a possible sum that I can get. If negative, what you have to do, you have to return int max, right? So we will be not going into that condition, because we are not we are having this condition that if k minus coin size is greater than equal to 0, then only we will go into the condition, right? So now what you have to do, you have to check minimum at each state, right? And what each state will be 1 plus minimum coin of k minus coins I, right? For the suppose we are having initial sum 11, right? And the first coin is 1. So what I will be doing is we will taking the minimum of answer and 1 plus minimum of coins plus 11 minus 1, that will be 10, right? So here you can see in that diagram as well that I am having 11 here, then plus 1 here, and 11 minus 1, 10. So this will be the final answer that I will be looking for, and in that way I will be calling function till I got to the base cases, and after that base cases I will be returning and getting to my final answer, right? So at each level I will be calculating the minimum of all these things, and I will be returning dp of k equals answer. So at the final state I will be having dp of 11 is equals to answer, and 11 was the sum that I was looking for. Now the condition arises, suppose if there does not exist any minimum case, right? So in the minimum coin, right, I do not go into the condition, and I always have the answer is int max. So what will happen is, if the answer is int max -1, then you have to return -1. They simply state that there is no combination possible, or no minimum number of coins by which you can get to the sum, right? Else, if the condition does not happen, what you have to do, you have to return a, that this is the minimum number of coins that you are looking for. So this was the explanation. I hope you got the solution right. So if you like this video, do give a thumbs up and make sure to subscribe to this channel, and thanks for watching.